talk about an ellipse. Ellipse is another conic section. It follows kind of the same rules as the circle, and even the parabola. It has H and K, where that represents the center, has foci, it has a couple of different things, the major axis and the minor axis, and all of it's pretty simple. An ellipse is kind of like a circle, except it's more like an oval. It's oblongated, and so it's either oblong through the vertically, which would be aligning with the y-axis, or horizontally, which is aligning with the x-axis. Because in a coordinate plane, if you think about a coordinate plane, your x-axis goes horizontally, and your y-axis goes vertically. Okay, and so those equations are only going to differ in their denominator, where the bigger denominator is. Wherever the bigger denominator is, that's what determines my major axis and whether or not it's horizontal or vertical. So let's start with the horizontal, because that's where my major axis, which is the longest distance through the ellipse center, when my major axis is horizontal, and then the minor axis is vertical. So these are two lines that go through the center of the ellipse. Okay, so if this is stretched horizontally, then the formula looks like x minus h squared over a squared plus y minus k squared over b squared equals 1. And I'm going to talk about the variables a little bit more in a second. All right, so this ellipse is stretched vertically, and so its major axis is vertical, it's up and down. And then here's the minor axis. Major means big or long. And so its formula is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. All right, so look at them. Notice that they both equal 1. They have to equal 1. And a squared is always the bigger denominator, and b squared is the smaller denominator. So when a squared, the bigger denominator, is underneath the y, then it is stretched in the y direction. Y goes up and down. So my ellipse is stretched in the y direction when the bigger denominator is under the y. So if my bigger denominator is under the x, then my ellipse is stretched along the x-axis in the x direction, so horizontally. So that's going to help us. The center is always going to be HK. It is a point in the coordinate plane. The H is the number being subtracted from the x. The K is the number being subtracted from the y. And an ordered pair, and I should have wrote that on this side. In an ordered pair, x comes before y. So the x is what is being subtracted from the x, or the h is what is being subtracted from the x. And the k is what is being subtracted from the y. The length of the major axis, so however long this long one is determined by 2 times a. So I'm going to take the square root of the bigger denominator, whatever it is, I take the square root, and multiply it by 2. For the minor axis, that's the short one, I'm going to take 2b, it's the length of 2b, so I take the square root of the smaller denominator and multiply by 2. Now I need to find c. C is going to be used in my foci. My foci is a distance on either side, the exact distance on either side of my center. And so it depends on whether or not I'm stretched vertically or horizontally, which formula I use. It's the same formula, it's just adding or subtracting to the x or adding or subtracting to the y. Of course, this one would be adding or subtracting to the y, and this one would be adding or subtracting to the x. Okay, but first I have to find c, so I use this formula a squared minus b squared. For the foci, if the bigger denominator is under the x, so it is stretched horizontally, then my foci is going to be at h plus and minus c. So I'm adding and subtracting from the x value of my center, and then just k, because it's going to be to the left and to the right of the center. It did not move up or down, so the k remains the same. If my bigger denominator is under my y, so it is stretched vertically, I'm going to be adding and subtracting from the k. So it would be h and then k plus or minus c. Okay, let's try another one. I want to identify where my bigger denominator is. It is underneath the y. That means this oval is going to be stretched long ways in the y direction. This is your y direction, so vertically. So I know it's going to be elongated like that. Okay? The center is always going to be my h, k. And so h is the number being subtracted from x, so my h is positive 1. K is the number subtracted from y, so my k is negative 3. So the center of this ellipse is going to be at 1, negative 3. So 1, negative 3, put your center. The major axis is 2a. Well, a is 4, because the square root of 16 is 4, and 2 times 4 is 8. So the length of my major axis is 8. From end to end, it counts 8 units. So in the center, it's going to go 4 above and 4 below. And why am I going above and below? Because it's on the y. So it's up and down. So I'm going to count 1, 2, 3, 4, and then 1, 2, 3, 4. Okay? Remember, I'm going to connect my outside dots because that's the center. All right, the minor axis is 2b. Well, b is the square root of the smaller denominator, so it's 2. And 2 times 2 is 4. So the length of the minor axis is 4. So all the way from the far end to the other end, it's 4 units. So through the center, it's 1, 2, and 1, 2. And let's connect it. And y'all saw my last one. It's horrible. Okay. So this one's a little bit more elongated than that other one. All right, for my c, it is always going to be c squared equals a squared minus b squared. So I'm going to come down here and work it out. So a squared is 16 minus b squared. So c squared equals 12. So c is the square root of 12. So c is 2 square roots of 3. So where is my foci? It's always on my major axis. My major axis is the longest distance. So it's this one. So it's going above and below the center because that's where my major axis is going up and down. So who am I adding and subtracting to? The y, because that's up and down. Okay? So my foci is going to be at 1, negative 3, plus or minus 2 square roots of 3, okay? Because it's h and then k plus or minus c. Okay, the last two problems were already set up for us, and this one is not set up for us. So what we need to do is we need to group our x's together with our y's, so we're adding our x's and our y's, equal to 1. So the constant is going to be over there on the right side, and my variable expressions are going to be on the left side. Well, this is okay. That negative 16y is where it needs to be. But this, and this all need to come over here to the left. And this 52 needs to go to the right. So let's just shift this stuff around. So first, I'm going to add 2x to both sides since that's negative 2x. And so that gives me positive 2x squared, x squared, 2x squared, not 2x. And then I'm going to add 8x, so plus 8x. Then I'm going to add y squared plus y squared. Minus 16y is in the correct spot. Equals, I'm going to subtract 52, so negative 52. You have to be really good at elementary algebraic skills to manipulate these and move this stuff around. Okay, so now I'm going to group together my x's and my y's, and I'm going to do complete the square so that I can get the equation, the equations that I need. But to complete the square, remember that this leading coefficient has to be 1. So I need to divide out the 2. And when I divide out the 2, I have x squared plus 4x. This one's already good to go, plus y squared minus 16y equals negative 52. Okay. All right, I'm going to complete the square, so I'm going to rewrite this and leave some spaces because I know I'm going to be adding. Remember, whatever I add on this side, I also have to add on this side. If you don't, you're going to get it wrong. This is a balanced scale. Whatever you add over here, you have to add over there. Whatever you subtract over here, you have to subtract over there. So you have to do it to both sides. Okay, so to complete the square, I usually will go x squared plus 4x plus blank plus y squared minus 16y plus blank equals negative 52 plus blank because I have 2 blank spots here. Now we have to be careful because when I find this number, I'm not just taking this number and adding it over there. I have to take this number times 2 and then add it over there. Okay? Whatever this, if there's a coefficient outside of the parentheses, we have to multiply that first and then add it over there. Okay, so complete the square. Half of 4 is 2. 2 squared is 4. So I'm not going to come over here and just add 4. 4 times 2 is 8, so I'm adding 8. Okay, half of 16 is 8. 8 squared is 64. 64 times 1 is 64. Okay. So over here, it's going to be 2x plus 2 squared plus y minus 8 squared equals 20. I do not want 20. Do not want 20. Can't have 20. I need this to be a 1. A lot of students will stop right there. No, this has to be 1. So how do I make it a 1? Well, if I divide a number by itself, it makes 1. But I can't just divide this by 20. This has to be divided by 20, and this has to be divided by 20 because it's a balanced scale. So this reduces to x plus 2 squared over 10. This doesn't reduce. It's going to remain y minus 8 squared over 20 equals 1. Now I'm good to go. It's exactly what it needs to be. Look, here is my bigger denominator. That means this ellipse is stretched vertically because y is vertical. My center is hk. H is what comes from x. It's the number being subtracted from x. So h is negative 2. K is the number subtracted from y. So k is 8. So my center is at negative 2, 8. The length of my major axis is the square root of the bigger denominator times 2. So it's the square root of 20, which is 2 square roots of 5. A is 2 square roots of 5, by the way. And B is the square root of 10. Because A is the square root of the denominator, and B is the square root of the smaller denominator. Okay, so times 2. So my major axis is 4 square roots of 5, because this times 2 is 4 square roots of 5. My minor axis is 2 square roots of 10. Alright, so I need to find C so that I can find my foci, and C is always going to be C squared equals A squared, which is 20, minus B squared, which is 10. So C squared equals 10, so C is the square root of 10. Okay, where's my focus going to affect? My focus is affecting wherever the bigger denominator is. My bigger denominator is here with this y and this minus 8. So my foci is affecting this 8. That's where the bigger denominator is. So this 8 is where I'm adding and subtracting for my foci because that's where the bigger denominator is. So the negative 2 doesn't change. The 8 is going to be plus or minus whatever C is, the square root of 10. Okay? Okay, let's try another one. We need to gather up all our x's in one spot and y's and then equals the constant. So my x's are going to be 4x squared plus 16x plus 5y squared plus 10y equals positive 79, because add 79 to both sides. And then I'm going to complete the square. Now remember, when you complete the square, the leading coefficient has to be 1. So I'm going to divide out the 4. When I divide out the 4, I get x squared plus 4x plus something. That's how I complete the square. Plus, here I'm dividing out a 5. So when I divide out the 5, I get y squared plus 2y plus something equals 79 plus something something from the x and something from the y. Okay, so don't forget to do that. Okay, half of 4 is 2. 2 squared is 4. I'm not just taking 4 and adding over there. I have to go 4 times 4, which is 16. Half of 2 is 1. 1 squared is 1. 1 times 5 is 5, so I'm adding 5. So here, this factors to be 4x plus 2 squared. This factor to be 5y plus 1 squared. And let's see, 21 and 79 would be 100. I was about to grab my calculator, we can do that one in our head. I don't want 100. I need this to be 1. So in order to make it 1, I can divide a number by itself, and if I divide a number by itself, it gives me 1. So I'm divide by 100. Everything has to be divided by 100 because it's a balanced scale. And then that's going to reduce. That reduces to be x plus 2 squared over 25 plus y plus 1 squared over 20 equals 1. Now I'm good to go. Once this equals 1, I can figure out my center, which is h and k. My h is in the first spot, so it comes from x. It's the number being subtracted from x, so it is negative 2. My k is in the second spot, so it comes from y. It's the number being subtracted from y, so it's negative 1. That's my center. By the way, I just got ahead of myself. Here's my bigger denominator. It's underneath the x. So this oval is going along the x-axis, or it's parallel to the x-axis. It's elongated horizontally. So my major axis, well, let's figure out what our a and our b is. A is the square root of the bigger number, so a is 5. B is the square root of the smaller number, so it's 2 square roots of 5. Because the square root of 25 is 5, the square root of 20 is 2 square roots of 5. Okay, so the length of my major axis is 2 times a. So the length of my major axis is 10. So from this center, which goes, by the way, the major axis goes this way, I'm going 5 on this side and 5 on this side, because the center is in the middle of 10, so make sure when you're graphing you do that. All right, the length of the minor axis is 2 times b. Well, 2 times b would be 4 square roots of 5. I didn't leave myself a lot of room here. I need to find c. What I know is that c squared equals a squared minus b squared. So c squared equals the big denominator, which is 25, minus the small denominator, which is 20. So c squared equals 5. So c equals the square root of 5. All right, let's talk about this. The focus is on the major axis. The focus affects where the bigger denominator is from. Here's my bigger denominator. So my focus affects this 2 right here. That's what my focus affects, because that's where my bigger denominator is. So my focus is going to be negative 2 plus or minus the square root of 5, and then that negative 1 is not affected.